Hello friends and welcome to PyShine. In this video, we will design a cache server to provide a live video stream to the clients from a drone system. We will make 3 Python codes. First, the drone system will make a dedicated socket connection to the cache server to send its video stream. In the second code, the cache server will buffer the video stream and listens for the clients. In the third code, we will make the client socket connection, which will connect to the cache server and show the video stream. Alright, so let's talk about the whole network. Let's say we have a drone system, which can use Python to send its video over the Wi-Fi to a cache server. So this drone system will be like a small server, which has limited energy and computation resources. To broadcast this video stream to multiple clients, we require a cache server that has enough computation, network and energy resources. These resources are required because sending a live video stream to clients would require multi-threading. Each thread will send a video stream to a client. As the number of clients will increase, more threads will be used, which will require more computation, as well as network resources. We will make these Python files for each system. In this scenario, at least the drone server and the cache server should be connected to the same Wi-Fi network. Let's have a look at the key points of a cache server. A cache server is a dedicated server that acts as a storage for web content, usually to have it available in a local area network. A cache server acts as a proxy and stores previously requested information from the internet, locally and temporarily. By storing frequently requested information, bandwidth is saved and browsing speeds up. The access to already cached websites become faster since they are served locally, as opposed to data, which is still traveling from across the globe. Multi-threading has become extremely important in terms of the efficiency of application due to the introduction of multiple cores. With multiple threads and a single core, an application would have to make transitions back and forth to give the illusion of multitasking. However, with multiple cores, the application can take advantage of the underlying hardware to run individual threads through a dedicated core, which makes the application more responsive and efficient. Alright, let's start the coding. Our first file is drone.py. It is highly recommended, if required, that you watch our previous tutorial about the fundamentals of socket programming. The link is available in the description below. So let's start by importing the essentials. The server socket is created for the sock stream type internet family. Here, we have to enter the IP address of the system at drone side. Socket address is a tuple of IP and port number. So let's bind and let the server socket listen on this address. Now, we make the function named start video stream, so that, when a client or cache server is connected, the video stream will be started. The drone system can stream either a stored video or from a live webcam. Then, it will send frame by frame the data as shown. For the demonstration purpose, we show the image, however, on the system you can comment it. We will keep the drone server alive, in a while loop, so that once running, we no need to run this code again. Once the cache server will connect, it will get a video stream. That's it. Let's code the cache-server.py. Similarly, we will create the server socket here. We will make the frame as a global variable, so that it can be accessible to any thread. Here, enter the IP address of the drone system, according to your settings. Here, we will start a thread that will receive video from the drone and assign each frame as a global variable. Next, let's make a function to serve the client each coming frame. Similarly to the previous tutorial, let's run each client on a separate thread. The client.py code is rather simple and similar to the previous tutorial. Here, each client should know the IP address of the cache server. You can enter the address accordingly. Let's save and run the code on two machines. First, we have to run drone.py. The drone system is listening for the cache server, so let's run the cache-server.py file on a different system. As you can see that now the drone video is streamed to the cache server. Also, notice the relative IP addresses. It's time to start the client.py codes in separate terminals. Now, let's disconnect the connection between drone system and the cache server. Finally, let's close the cache server as well. That's all for today. Have a nice day and see you again.